So we just went over in our lesson on the 5 basic types of chemical reactions. And so we're going to do some guided practice, and we're going to be using the balancing chemical equations worksheet that we used for our classwork practice during our live sessions. Now, before we look at the examples, the guided practice, I do want to draw your attention to a very important resource that you guys have, and it's your chemistry reference tables. And specifically, I have attached this in the module in Canvas, and it's specifically page 6 from the module where you'll have your reference tables. You may want to, if you haven't printed out the entire reference table, you might want to go to page 6 and then print this out, because this will be a good thing for you to refer to and to put with your notes. But these are just simple guidelines for predicting the products of your selected types of chemical reactions. And notice there's a key here where a capital M stands for a metal and an NM stands for non-metal. Now, when you're abbreviating the types of reactions, I've written the abbreviations out to the sides. So for a synthesis reaction, you can abbreviate that SYN. And notice I've highlighted the general format for a synthesis reaction. This is the one that we wrote down in our notes. But this also has 2 other types of synthesis reactions where you have a specific base formed or an acid formed. But in either case of your synthesis reactions, notice that there's only one product. That's the key feature of a synthesis reaction. Then we have decomposition reactions. So to abbreviate decompositions, you would want to put DECOMP. And the main type of decomposition reaction that you're going to be noticing is going to be a binary compound decomposing for the most part. But notice here, it's just the opposite of a synthesis. Decomposition reactions have just one reactant and they break apart. Decompose means to break apart. Notice all of these examples have only one reactant and then your yield sign, and then it breaks apart into multiple products. So synthesis and decompositions are opposites. Synthesis have only one product, whereas a decomposition has only one reactant. And then we have our replacement reactions, single and double replacement. You abbreviate single replacement with an SR and double replacement with a DR. Now, the main type of single replacement reaction that you're going to see is where you have a metal-metal replacement. But you also can have a halide-halide replacement, which would be dealing with your halogens. The main thing with a single replacement reaction that you want to look for is you will have a single element and then a compound on the reactant side. And on the other side, you will also have a single element and a new compound. And so one thing will have replaced a similar item, but a single thing has been replaced or kicked out, as I talked about in the video lesson. Then we have our double replacements. With a double replacement reaction, all compounds are going to be ionic and they're all going to be in aqueous solution. Remember, that means they've been dissolved in water. So here you have AB reacting with compound CD. And notice it forms 2 new ionic compounds. 2 things get replaced. The format, or the kind of thing you want to look out for, the pattern that will occur here, the double replacement, is if you look at your reactant side, the metal in the first reactant will combine with the nonmetal or the anion in the second reactant. So outer joins with outer. Notice on this side, AD have come together as the new compound. And then the inner 2 will come together. The B and the C will come together. And notice CB are together here. One thing that I do want to point out to you is that the metal is always written first, or the cation is always written first in your ionic compounds. That is important. And then finally, we have our combustion reactions. Remember, combustion means to burn. So it's what happens like when you burn gasoline or any of your hydrocarbons, the combustible hydrocarbons. So the definition of a combustion reaction is when your hydrocarbon reacts with oxygen. Of course, oxygen is present in the atmosphere, and it forms carbon dioxide and water. That's going to be what you see for a complete combustion reaction. Remember, for the combustions, this part here is going to always be the same. So I wrote for my generic hydrocarbon formula, C sub X H sub Y plus O2 yields CO2 plus H2O. So I just wanted to just point that out to you. That would be a wonderful reference piece for you to use. And now I'm going to go straight to the classifying. So from the notes, you already have these classified. These were the notes examples that I used in the video lesson. And again, this is the classwork balancing chemical equations worksheet. So as part of your homework, what I want you to do is I want you to classify the remaining chemical equations here as to one of the 5 types. All right, so let's go through these. We're going to pick up on number 4 because that is the first one that we have not done yet. Again, 1, 2, 3, 5, 7, 8, and 9 were all covered in the video lesson that you should have already watched. Okay, so let's classify number 4. What I'm going to do is a few of these kind of with you, but I'm going to ask you to pause, and then you try to complete some on your own. And I'm going to keep talking through the answers, but I want you to try some of these on your own once I do a few more, and then resume the video once you've finished, and then see how you did on that. That's the best way to check for understanding. All right, so on number 4, what you want to do is you want to locate your yield sign. So always find your yield sign, and so here's the arrow, the yield sign. And you want to kind of assess what's going on here. Well, you'll notice you have 2 reactants, H2 plus O2, and it's forming only one product. Now, the type of reaction that only has one product is known as a synthesis reaction. This has only one product, so therefore you want to call it a synthesis, so you'll put SYN for that one. One product is a synthesis reaction. Let's look at number 6. Now on number 6, there's a lot going on here. I want you to notice there's 2 reactants and there's 2 products. So that means it cannot be a synthesis or a decomposition reaction. So it's one of the other 3. Now I want you to notice you have a compound plus a compound yielding a new compound and a new compound. So since there's 4 total compounds, it cannot be a single replacement reaction because a single replacement reaction has at least one element by itself on each side. These are all 4 compounds. Now, if you look at it closely, notice you have aluminum here and then there's sulfate there. And I want you to look what happened. Outer 2. Now look what happens over here. Aluminum and sulfate are together on this side. Notice the outer 2 ions in the compound came together on this side. And then potassium and bromine are the inner 2 components, and notice potassium and bromine are together over here. So they just swapped partners. So that is a double replacement reaction. Hopefully you see double replacement. Now I do want to talk about, because we have already answered 7, 8, 9 as combustions. We've identified those. I just want you to look at these, y'all. This is important because the thing about combustions is they're the ones that are challenging to balance. But they're the easiest ones really to identify for me anyway. I want you to notice from the oxygen over how these all look exactly alike. I also want you to notice that they all start with a compound that consists of only hydrogens and carbons. So we call those hydrocarbons. So this fits the format C sub X H sub Y. That's your hydrocarbon. Plus O2 yields CO2 plus H2O. So that is a combustion reaction. They are really easy to identify once you see what to look for. All right, let's look at number 10. So here again, we have iron and hydroxide. Notice the outer 2 ions come together on this side, new compound. And then you have sodium and chlorine. They're the inner two ions. See how they're together on this side. So outer joins with outer and inner joins with inner. So this is another double replacement reaction. Two things replaced, or they swapped partners. All right, let's look at number 11. Again, find your yield sign. So here's our yield sign right here. And notice you have two reactants and only one product. The only type of reaction that has just one product, again, is another synthesis reaction. Now, I'm going to challenge you to go ahead and pause the video and go ahead and try 12 through 21 on your own. And then once you finish classifying, resume the video and then see how you did. I'm going to go ahead and continue. So hopefully you've gone ahead and done these on your own. And so if you look at number 12, remember in balancing, I told you a little trick in class that when you see hydroxide on one side and water on the other of the yield sign, it's best to write your water as HOH. That will help you see what's happening a little bit better. So notice here sodium is just an element, and then we have a compound. And on the other side, you have a brand new compound and a different element. So element, sodium, notice he kicks out hydrogen. Notice hydrogen has been replaced. Hydrogen got kicked out. And now sodium and hydroxide are together. So remember the little analogy of going to the dance? Sodium's dancing with hydroxide. So this is a single replacement reaction. Number 13 has only one reactant and two products. So this is a decomposition, because it has only one reactant. All right, let's look at number 14. You got S8 plus O2. Here's your yield sign, and you have only one product. Notice, find your yield sign, one product. This is another synthesis reaction. Now 15 and 17 and 18 are more complicated, so you will never have one like that to identify for this level of chemistry, so don't worry about that for now. 16, hopefully you said it was a single replacement reaction because you have an element and it's going to kick out another metal. And so magnesium got kicked out, a single thing got replaced, and now you have potassium and bromine, your new compound, single replacement. Number 19, here's your yield sign. Notice you have only one product. So that is another synthesis reaction. Next, we have compound plus a compound. They're both ionic, forming a new compound and a new compound. So this is a double replacement reaction. Finally, outer and outer, hydrogen and nitrite. And then inner and inner, sodium and sulfate. There's sodium and sulfate together. There's hydrogen and nitrite together. So this is another double replacement reaction. So how'd you do? Hopefully you're catching on. If you ever get stuck, refer back to your notes, look at your reference table. And of course, if you have any questions, we will address those in class. Thanks.